Hi all, this is Kiran from Locus Eduventures. So in this lecture video I am going to cover the equation of circle circumscribing a triangle. So let's say we have a triangle and the equation of the sides are given, that is a1x plus b1y plus c1 equal to 0 is the equation of the first side. In short form we will represent this as L1 equal to 0, and the equation of the second side is suppose a2x plus b2y plus c2 equal to 0. In short, we will represent this as L2 equal to 0. And the equation of the third side is say a3x plus b3y plus c3 equal to 0. In short, we will say L3 equal to 0. So we have a triangle ABC for which the equation of sides are given. We have represented in short form notation L1 equal to 0, L2 equal to 0 and L3 equal to 0. So we will now see how to find out the equation of circle passing through these 3 points ABC. So let me draw the circle passing through these 3 points ABC. So what is the circle called as? Circumcircle of the triangle. Now here, without finding the coordinates of vertices ABC, we will straight away try to find out the equation of the circle using the equation of the 3 sides. So let's see how we can do this. Now you can see that whenever you multiply two first degree equations, you are actually going to get a second degree equation. And we know that a circle equation is going to be of course a second degree equation in x and y with some conditions imposed on it. So let's see how we do it. If I consider L1 multiplied with L2, so this is first degree, this is first degree. When I multiply these two, I get a second degree expression. Only the left hand sides I am going to multiply without 0. And I multiply these two, L2 with L3, that is multiply the left hand sides without 0. So I multiply both the expressions. Then L3 multiplied with L1. So when I write down an equation of this form with some constant lambda and mu here, where lambda and mu are parameters, that means varying constants. So this is going to represent a second degree equation in x and y. But we need to check whether it is going to be satisfied by ABC or not. After that we will check when it is going to represent a circle. So if you observe, A lies on L2 and L3. That means when you substitute A, L2 and L3 are zeros. So when you substitute A in this, since L2 is 0, this term is 0. And L3 is 0, so this is 0, and here there is L3 which is 0, so you can say that whenever I am equating this with 0, it is going to represent some equation in second degree in x and y satisfied by A. Similarly, you can see that when I substitute B, L1 and L3 are 0. So since there is L1, this is 0, there is L3, so this is 0, and both L1 and L3 are there, this is 0. Just like that, when you substitute C, L1 and L2 are 0, so it will become 0 equal to 0. That means this equation is a second degree equation in x and y satisfied by the 3 points A, B and C. Now when is the second degree equation going to represent a circle? The conditions for a circle we are going to write down. So the first condition that we are going to write down is coefficient of x square should be same as coefficient of y square. So this is the first condition we need to impose. From this you are actually going to get an equation in lambda and mu. And what kind of equation is this? A first degree equation lambda and mu. So this will give you an equation in lambda and mu. Similarly, if you apply one more condition for a circle, that is coefficient of xy term equal to 0. So we are going to get one more equation in lambda and mu. So this will give you an equation again in lambda and mu. An equation in lambda and mu. So you can see that there are two equations which are getting here and there are two unknowns. So solving these two equations, we are actually going to get lambda value and the value of mu. So that means these are the values of lambda and mu for which this equation is going to represent a circle. And through 3 non-collinear points you can have only one unique circle. Definitely for this value of lambda and mu it is going to be that circle only. So to get the circle equation, just substitute the value of lambda and mu in this equation. You are going to get the equation of the circle. So this is how you find out the equation of circle circumscribing a triangle whenever the equation of sides are given without actually finding the vertices. So I hope all of you have followed this video. So in the next video we are going to cover more on this topic, but instead of considering a triangle, we are also going to consider a quadrilateral being circumscribed by a circle. So in case you have liked the video, please refer to the next video also, and don't forget to subscribe.